Alright, so in this video I want to talk about cloth simulations and getting them into game engines, or in this case WebVR, WebAR. What you see here is, the typical air guy. I don't know what you actually call these dudes, but one of them is, they're both created in Blender and brought into Mozilla hubs. We've got a cloth simulation that's baked as a bunch of shape keyframes. That is the one on the left, and obviously it looks much more cloth-like. But it's also a lot more expensive from the point of view of file size and getting it into the game engine. Whatever your engine is, it's going to be a lot bigger. This is like 40 megs, and this one is only like 6. You can take this, it's going to load faster, have about the same effect, and save a little processing power, because in this case what I really wanted to show was that you can take this into augmented reality using this AFRAME and AFRAME or AR.js. There are now connections that allow you to use image targets to load models in your mobile device, or to do geolocation. And I have an example. Let's see. So I've taken this character. This is an example running off my phone, using the same character, using the bone-based method, and track that in space using, you can see it's a little jerky, and there may be a way of getting it smoother as in AFRAME, but the cool thing about it is that it's actually an object you can load from any web browser now in AFRAME, and it'll just work on your mobile device. And you can see it tracks as you get closer to it. It will get bigger, and it tracks based on location. Now this jerkiness that you see is probably like a smoothing effect that you could probably code, or you could do some sort of like lerp interpolation in the code. We're going to talk about how I created this and ways to maybe smooth it out. But I think it's really cool that you can actually get geolocation and image-based targets for augmented reality on a standard web page now using AFRAME and AR.js. So we'll talk about how to do that at the end, but I want to first talk about how to get this optimized cloth simulation baked to bones so that you don't end up transferring all of those shape keys to your object for import. So we will go to Blender, take a look at just the cloth simulation setup first. So this is the one with the physics and the cloth, and we could talk about that, but you can basically look up Ian Hubert's tutorial. If you don't know Ian Hubert, you should look him up on YouTube, and he has a tutorial that shows how to do this. But basically it's a cloth simulation in where we've turned on the cloth. Size will matter for this. So like this is pretty tall. It's actually really big, about 40 meters tall, I think. And I've just created a tube that's closed at both ends, and then taken another tube and just duplicated it and rotated it, and then did a Boolean to connect up the arms. And then I ended up like finishing out the points, connecting them up to the corners so that we didn't get any like n-gons, not knowing whether or not that would cause an issue with the physics simulation. So we have this tube that has cloth applied to it in Blender, and I'll go through and do a quick version of this. I don't want to show the whole thing because this is a lot. But you take the cloth, you set up your settings for it, and then you bake it. So you're going to have this cache, and you're going to, in this case, I've got 3,000 keyframes. So this is partly the reason for the size, because you could do a smaller simulation and it'd take up a lot less space. But I wanted to show that you could do a really large simulation in this case 3,000 frames worth of it, and then bake that to bones. And I'll show you the technique for that. So with this, to create this cloth simulation, we ended up creating some pressure on the, we'll do it again in the video, but we create some pressure so we get this internal kind of thickness and thinness where things bend. You see, like coming up out of this, and then it sort of bends here, but you get some pressure where it pushes it out there. The same thing with the arms, so that it actually looks like he's being inflated. And then what creates this floppiness is the weight of the physical points. So you've got this vertex mass right here. Let me go and I'll just be able to see it better if I delete the physics. Yeah, we'll just delete the bake. So I've set, depending on the size of your model that you're trying to simulate, we'll go back. So depending on the size of the model that you're trying to simulate, and then this wind force generator right here that you've got to kind of blow up on it to make it so that it looks like it's, it kind of blows it up instead of allowing it to fall to the ground. You'll have a physics or a weight mass set for each one of the vertices. Now again, that's going to vary too depending on the number of vertices you have on your model. So what I'm trying to do with this particular model is go as minimal on the vertex count as I can, while still having enough to get a good cloth simulation. So if, in other words, if I have like call it half as many polygons for this, it's not going to look very cloth-like, because cloth's going to have all of those wrinkles and stuff that allow it to kind of bend and have these ridges and bends and folds. And you can see this is kind of the minimal amount that you could probably get away with. It would probably look a lot better if I doubled the vertex count. However, if I double that vertex count, when I go to bake the simulation to shape keys, it's going to double the size of my, or quadruple the size of my file, because I'm going to have that many more vertices to have for each single keyframe. So it's kind of a balance to get the simulation you want for the cloth to look good, and then be able to bake the bone chain to get the same kind of simulation. So in my case, once we add the bones, we're going to lose a lot of this cloth physics. We're going to get the motion, the bends and the joint changes, but we're going to lose the stuff that makes it kind of cloth-like, this twist that you get there, where it would have much more cloth-like feel. So this is just one of those things you're going to have to play around with. We'll talk about things you could do to get a kind of blend between the two, but first I just want to show you what I'm talking about when I say bake to bone. If we turn on this armature and go to wireframe, you'll see I've got selected this chain of bones that goes up the length, and basically it's like let's see, yeah, one bone per 2 rings, and except for the base here where it's 3, but I've got 60 bones that go up the chain of this thing, and then split at the middle here, and then I have some arms that kind of offset going out to control that. And what I did, the reason that I did the 2 rings per bone, I could have done 1 ring per bone, but that would be kind of overkill because this thing isn't that bendy. Probably even 2, maybe less, but I wanted to show the point in that you can take this bone chain, and with each one of these bones in pose mode, you can add a constraint called damp track and have that track the ring that is corresponding to its tip. And when that happens, then you end up getting the bone chain tracking the physics simulation. So you can simulate the physics, not have the bone be attached to the mesh at all, simulate the physics and have that baked to get these bones that will follow the track. But what you're going to see though is, here's the deal, and this is what I'm going to spend a large chunk of this video explaining. cloth shrinks, especially when you've got this inflated pressure in it, and the bones don't. So these bone chains, as they start out, they're going to be stretched out to the length of the thing of the cloth, but when the cloth shrinks, it's going to cause the bone, the targeting, to kind of like clip or kink here, where the bones don't shrink, and so the rings get tight, close to each other. The bones are just going to kind of like bend. And what that's going to do is that'll end up creating kind of warps and twists in your model that will cause, once you get done and bake rig this mesh back to the bones, once you've baked the cloth simulation to the bones and then taken the cloth simulation out, we're going to go through this process. You're going to end up getting like this twisty mesh that's not going to look near as good. And that's because this damped track does not take into account scaling of the bones to the mesh as the mesh shrinks. So I have another version. Yeah, let's do this. I think this is it. Yeah. And you can see with it, when you go through these, that the bones don't kink because I have them actually stretching. And you can see that here in this bone, how it gets bigger, smaller, depending on the tightness of the rings. And the way you do that is because it's got this, this is once I've already baked all the keys. Let me open up the other one. Yeah, I think it's this one. Yeah, so this is the physics simulations before it's baked. The bones are following, but they don't kink, like in these areas where the mesh gets really tight. And the reason that is because if you go to pose mode and you look at the constraints, they look very different. They're not using the damp to. I'm copying location, copying rotation, copying scale of a second armature. I've duplicated the armature here. So this is the one that's actually tracking. Let me explain this. Excuse me. So this armature, which at this point I think is probably not tracking, or am I in, I'm in edit mode, so in pose mode. This armature, if you look at the constraints on it, it has stretch to, okay? And what I've done is I've disabled volume so that when it stretches, the stretch to, it scales the bone, because if I do a volume stretch on that one, let's see, the bone will get fatter. And I've also set it to swing here on the rotations. But the gist is that we want to set this stretch to and do the same type of tracking where we target, if we look at this mesh, look at its vertex groups. We've got a base ring. Let's go and edit. Select. So there's the base. And then we have ring 1. Select there. Ring 2. Select. So we've got these targets, these target rings, where I've gone and created a bunch of rings that go around the mesh just by selecting and then creating a group and assigning those to it. And those are what those bones are stretching to. Those are what they're targeting for their room. And because it's a ring, they'll target the center or the average of these vertices as opposed to pointing at a specific one. So this is a way you can target kind of a an arm ring or something like that and get the center of it as opposed to whatever the edge is. But the thing is when this cloth simulation is going, won't go when I'm in edit mode. And these, the cloth causes the ring to crumple. Then what it's going to happen is it's going to target kind of an average location of all these points in space and point towards that. And also, too, it's going to scale because I'm using the stretch 2 on the bones here. So let's go back to pose mode. So this bone, you can see where, let me hit F to center on it. You can see where it sort of stretches as it goes and gets smaller and tighter. Now, when you first do this, if you don't end up setting this rotation and swing to, you can see them slightly shifting and rotating as I change these. It changes the kind of technique or the method, and what happens is this bone, this volume, where it says maintain volume, let's see. Can't find it. Yeah, you can see where those get fatter or skinnier. That's the reason for turning this to none. See how it gets thinner there? Instead of that, it gets thinner. And then swing is going to just take the shortest distance as opposed to applying these. So what that does when we set these on each one of these individual constraints, let me set that back, and that we'll go through this again in a sec. Is that it will only scale on the vertical. Now, why is that important? Because like if this thing scales using this volume technique, it's going to make the places where it scales, in other words, this gets shorter, it's going to make it get fatter on the X and the Z instead of just scaling like the cloth is shrinking. And that's going to cause your bone that you're going to apply back to this to get fat, and it'll make the shape get fat. So turning this to none and swing, particularly the none on the volume, causes it to maintain its original mass, the ring, the mass of the cloth, but only get shorter, like it's stretchy. Okay. Well, like I said, we'll explain that in a second. But the point is, I've got this armature, which is actually tracking the cloth using the stretch 2. Now the problem is if I try to just bake this stretch 2 constraint to the bones themselves, which I could, but if I did that, because they are connected in a chain going up the length of the object, that scale that occurs on each one of these stretching bones will end up getting magnified and warped out the chain. So in other words, if I go trying to decide if I should take time to do it on this, I'll come back and show you when we do a shorter chain how it works. But so there's a reason why I'm not using this particular chain, is it won't look the same. It's going to end up getting all kinds of warped. So to avoid that, you have to duplicate this armature to this. And if you look at this armature, you'll notice a slight difference. You see how this one has a pose with one bone showing? And then beneath that bone is another bone. So they're a chain, right? This one has one base bone, and then all of the other bones are just flat within it. And what that does is then that scale becomes independent. It doesn't magnify that stretch throughout the chain, so it only stretches the bone. So if we go to look at pose mode, make sure I'm in armature. Can't figure out why. So if we go to pose mode here, each one of these bones has a copy location of armature 1 and copies its corresponding bone in the other chain, the one that I've hidden here. So you can see where they overlap and they get a little bit brighter when I turn it on. So I've copied the location here, copied the rotation here, and then I'm copying just the Y scale here, which means I probably didn't need to adjust the other settings on the other chain. If I only want to copy the Y, then it's not going to copy the Z, but just in case, I just made it so that it didn't have the volume in the other. And that's it. That's in world space to world space, and that causes these independent bones here to snap to the positions of the bones in the other chain and copy them, except for the fact that now, because they're all independently working separately, they're not in a chain that magnifies each scale throughout the chain. Each one can scale and track the other bone in the other chain, and they don't magnify the effect of the scale. And then from that, I can bake the chain, I can bake it to the keyframes, and then apply that bone to this mesh and get the character that I have, and it'll be much smaller. Instead of baking all these individual vertices as shape keys, you'll end up getting a character with an actual skeleton that'll be much smaller. All right, so let's do this. Let's go new. We're going to just mimic this process in a kind of minimal way. Let's see. Let's do add a cylinder. Let's make the cylinder relatively small so we can keep it simple. So we're going to go 16 on the edges, and then we'll go make it really long. Not too long, but to get the same effect. And I probably won't end up doing the arms. I might add them just to show. Okay, so then that's good. And then for the ends, we're just going to generate, yeah, an N-gon's fine for now. Okay, so now we have this tube. Let's go in and edit, and we're going to add a loop cut. And then with that, we're just going to duplicate it like this many times. Something like that. And we can shade smooth. Now, you don't want to, with a cloth simulation, you don't want to do the normal shade smooth and then go to viewport not viewport display, vertices and normals, and turn on this auto smooth so that you get a nice sharp edge there. Because what will happen is when you do that cloth simulation, this is going to cause everywhere that the thing kinks past whatever your angle is for the auto smooth to take a hard edge, and it's not going to look very cloth-like. So keep it at this, keep the end caps and keep it at this this smooth shaded but not hard edged on the corners kind of look. All right, so now let's take that and move it up. That's good. We will freeze that, so we don't have an issue with the transform. So we're going to apply all transforms. That's going to shift its origin point down to the base. Actually, let's don't do that yet. I want to duplicate since we're going to do the arms. I just undid the set transform. So we're going to duplicate, copy and paste. I'm going to rotate, and I'm holding down Control so that it's rotating on the 90 degrees, or on the points. Scale this. I'm going to scale it a little bit out too, and we'll just put that up there. All right, so there's his arms. Let's do it one better, and we'll make sure we shift this and put it in between two loops so that we don't run into some issue crossing over. That'll work. Yeah, that'll work. All right, so now we can do a Boolean where we take this and add a modifier, Boolean, union, and the arm. Okay, and then apply that. We'll get rid of the arm. And now we have our shape there. But what's going to happen is we need to go back into edit mode and fix these points so that you don't end up getting like some weird geometry. So I'm just going to add a loop cut to connect these center points to there. Same on the back. And trying to decide if I should join them up. Yeah, why not? We're just going to merge just for the sake of speed. This may not be the way I would normally do it, but I'm just merging these points. And probably for this, yeah, we can go and merge to this one. So I'm just selecting the one that I want to merge to last. Wait, not this one, to this one. And this one to this. Do the same thing here. So I'm just hitting G to repeat the command. Yeah. So then from that, we've got, this is a quad right here, and this will end up being a quad. So we can right click and connect. So now we've got two quads. This is not a great quad because it's caving in on itself, but that'll be fine for cloth. We don't really care. Actually, I wanted to join this one to this, and this to this, and we can just lose this edge, dissolve, just keeping it all quads. So probably the same. So there's a little bit of manipulation here. So connect, and quad. Same thing here. We'll lose these triangles in a sec. It's not that important that we keep it quadded. It's just, in my opinion, kind of easier to tell what's going on when you do that. If you do the, if I try to triangulate the whole thing, sometimes there's too many, and the edge loops don't select evenly around. So we'll do is dissolve those. So now that's all quads, and this is 2. All right, so there's our guy. Not too carefully constructed, but it works. We'll save this, and I suggest saving often when you're doing this physics simulation stuff because you can mess up pretty easily. So let's call this toot cloth. Save. All right. Now, let's get this thing interacting with as a cloth. So what we need first is we're going to put a plane in for it to collide on in case it needs to, just to simulate what the ground would be. So let's add a plane. Scale that up. Not too big, but oops, did I add that in? Yeah, I did. Undo. Accidentally added that plane in edit mode, which means it's part of the cloth. I could have separated it, but we'll add it. Go into object mode, add mesh. I want this to be a separate object, plane, scale it up. apologies for that. And now we will freeze or apply all transforms for that, so we lose the scale on it just in case. This one can have apply all transforms to get it at the base. So now we got that. And we will set, in terms of physics, we will add a trying to remember if it's a rigid body. We don't want it, we just want it to collide, so we're just going to make it collision. That may only work on particles, but we'll see. We're going to make it collision for this, so it doesn't have like any kind of physical, it won't drop. And then we're going to make this cloth. And the nice thing here, you can select cloth, and you can use this little pie menu pull down or hamburger menu and give it whatever cloth style you want. Somewhere between silk and cotton is what we want. Silk has a really light vertex mass, and cotton, you can see it's about twice silk, but also too, it has some more tension. If you look at the tension settings when I change them, silk has like a 5 tension and a compression of 5 and shear 5 stiffness, and then cotton is 3 times that. So what you can do, let me just show you what silk simulates like. Once you've got that applied, you can get it in the screen and then hit play and watch it just fall. So you can tell there's not a whole lot of geometry for it to do its thing with, but it sort of simulates like cloth. One of the things we probably need to do is like it's going through itself, so we need to do some self-collision. So if you go down here to set collisions, object collisions, and just do self-collisions right here. Then when you hit play, it will self-collide and kind of collapse on itself, and that forces it to fall in a more realistic way. You can also see where it's sort of colliding, loses the base shifts, and in our case we want this, we want the base to act like it's connected to a fan or whatever's blowing this thing up. So if we go into edit, let's do X-ray, select our vertices right there. We're going to make a new vertex group called base and assign them. And then when we go back out to cloth, let's turn off X-ray. Go back out to cloth, and you can set the, trying to find pin. Yeah, pin group under shape to base, and that will mean that that holds still. So if you're making a flag, you'd have some vertices where it'd be hanging from something, that would be the pin group, and you'd make a vertex group for that. So now when we simulate, the base stands still and he kind of flops down on himself. So another thing that's going on, if we look, you can see there's this weird, see that flicker going on in the tip right here? That's because we don't have any polygons for those end caps. Right now they're just empty. So if we go into edit mode, see that we want to connect them up into quads if we can. So let's just select vertices and connect that. Okay. connect across this one. And then we'll make some quads. Give it enough detail so that it can collapse. Now we've got, yeah, that's all quads. Since the base isn't really part of the cloth simulation, we'll leave it alone for now. It should be okay. So now you can see where the caps don't do their little weird flip-flopping. So it looks much better. So that's how we get our cloth simulation. Now he's not really blowing around in the wind, or any kind of doesn't look inflated at all. So we can add, let's take a look at our weight here. So right now he's got the weight for silk, which is what we set, and the tension and compression and shear for silk. Let's make the weight a little bit heavier so it falls quicker. We're just gonna make it 3. See what happens. See how it falls in a different way, and it looks a little bit heavier, which is good. It looks kind of stiff though. So let's just see if we go 8 on this, somewhere between silk and cotton. Now the stiffness in part is partly because there's not very many polygons, because I kind of went low end on this. If we wanted to make it even better, to get a much better cloth simulation, we could add subdivision to get it higher. So what we can do then is we'll add that before the cloth, because we want it to be simulated. So we just move that up in the chain here. So he's going to have now twice as many polygons, maybe too many, but you can see where the simulation starts to look much more cloth-like because it's a higher poly count. And that's just going to be for you. It's going to, how much do you want to have to go back and how much do you want to simulate, and how much do you want to go back and have to rig up with bones? So I'm trying to decide if I want to even show that. See, the thing is we've got kind of too many polygons. See that they aren't showing up right now, but if I apply that, you notice how the count goes up. See, that's a lot of polygons on the vertical, and not so much on the, it only added, we didn't really get them where we wanted. We could almost even do ourselves a favor, and instead of doing that, just go back and do edit mode, take our loop cut, and just add a loop cut in between each joint, because we've got plenty on the lengths, but we don't have much this way. So I'm going to do that. Get them where they count. You kind of want square polygons for the cloth. You can get away with not having them, but the more square the better. You'll get a lot less. You'll get more of that wrinkling tension kind of going. And let's look at it without. And in that case, we could add, we could basically take these points here and connect them across like that. To get more in there. Do it across the back. Now it created some triangles, but I'm not too worried about that. All right, let's see what that simulates like. All right. And sometimes it's faster if you do it in wireframe. So So yeah, you can see it's behaving more cloth-like. And if we did a subdivision on it, it'd start to look really good. Let's do that. So I'll add a subdivider. Move that up. Let's go ahead and apply it. So now if you look at the keyframe, the polygons, this is overkill, but just wanted to show you what it would simulate like if we did that. Obviously it's slower, but you can see where the cloth takes on the wrinkles and the folds and bends that cloth would have much better. So I'm going to lose those polys because I don't want them. I want to keep this fast, so we'll get rid of that. I'm back to what I just manually subdivided. And what we'll do is, let's save. And then we need to add our wind. Well, let's take and make our cloth seem a little more inflated. So if we go to physics and take pressure, a little pressure goes a long way. So let's do like 0.01 and just see what happens with that. Try the simulation. So you can see where it looks like it's fatter now. When it bends, it's like it's got some air inside of it. And that looks a lot better. It may even be too much pressure. But let's add our wind now and see what happens. So now if we add a I think the pressure maybe, let's see. Like I said, a little pressure goes a really long way. Let's go down to like 2. See what happens. Yeah, now he's starting to kick himself with the wind. So if we increase the falls, but if we increase the wind, it's going to cause him to drag more, and he'll end up flailing around a little bit, a good bit more. We could probably lower the weight just a tiny bit too, but let's see if we can just do it with the wind. I like to keep the weight pretty heavy so that he does fall or wants to fall more. Otherwise, it ends up looking kind of too stiff. Let's crank that up. Let's see. Yeah, that was a good whip. Yeah, that's great. So you can see these little like windy S-curves that come from the noise and the wind and the twisting. Also the tension on the cloth. Like I said, he's starting to twist her around and do like a little shake. That's great. All right, that's good enough for showing you the next part. Let's so he kind of does his little wig. Yeah, let's save it. All right. What we'll do is we'll bake this and then save the cache. So select our. I'll show you how big the cache can be because it's basically baking point mesh for each one of these vertices. So if we hit bake. All right, the bake's done. Here's our simulation. Okay. Kind of wobbling around. That's good. It's not great, but it's a start. So now, if we baked that, let me show you the way we would bake that. I'm going to save this as a different. Let's call this to bake. Now this means this is going to change our this will change our cache. So we'd have to bake again if we open this one. So when you save this as a different file, it's going to lose connection to its cache unless you. And I don't really know of a way to load individual caches, but you'll see what I mean when we do this. So if you wonder this, just you'll have to bake again. Now that we've saved another one, well, maybe. Yes, yeah, it's not simulating now. That's because we lost our cache. But I've got a backup, so that's what I wanted. Now I can go back to the one that I did bake. This one. Sure. So now here's the one. You can see with this dark blue line that we do have a baked cache, and there's our simulation. Okay. So now if we want to take that and get the baked shape keys, here's how you do it. It's a little bit roundabout, but it's what works. So take this, and this is the method that I don't recommend. This is the method that will give you the true cloth kind of look, but it's going to be the larger file size, so it's not going to be easily portable to mobile platforms. If you wanted to do that augmented reality like I showed in the beginning, this is not the way to do it, but this is a way to get baked shape keys into some game engine if you don't care about the file size. So under edit, go to preferences. You're going to want to do, let me think about this, LW, no, point cache, yeah, that's, no, is that it? No. It's, I'm trying to remember the name of the file. It may actually already be. Import export is what it's going to be, and it is. Seeing if I've already got it turned on. Yeah, it's this new tech MDD format. It's mesh shape keys. So what you would end up doing then is looking for, if you don't have it, just type in new. Then you're going to have this. You can enable that for import export. Select your mesh file, export this lightwave point cache. That's why I was looking for lightwave. .mdd. You want to do that and take it a place. It's going to be tell it which ones you want to export, and toot cloth is what we want to export. So we're going to export that, and let's look and see if it did. Then you'll get file, and this file is 14 megs, the MDD. So when we import that, if we select this, or if we go file import now and look for that right there, then when we import it, it's going to bring it in, but it'll bring it in as a bunch of keyframes. So now if we go to our mesh here and select, yeah, I think it turned it off automatically. So we don't need, oh, I was on the wrong mesh. Turn off our cloth. So now it shouldn't simulate, we've lost our cloth, but the keyframes are baked, so it's actually on every individual point. And that's how we can have these keyframes baked. And the nice thing is that it does a shape key for each one, which is also why it's really large. But you can now export this. So if we wanted to export this as a GLB for our if we wanted to export it as a GLB for say import into our VR engine or WebGL, whatever, which is the standard GLB or GLTF is the format for that, then we would get our object with animation, and it would be baked, but it's going to be really large too. So let's do that. We'll export as a GLB. Now on this, you're going to want to make sure you've selected the object you want to export. Do selected objects only. And on the geometry, keep all that. Animation, and you're going to want the shape keys. And you're going to want to sample the animation. So, excuse me. Sample this animations on the singular frame rate, one frame. Actually, you may be able to get away with, I think it's going to want the shape keys. Excuse me. Let's just try it this way. You won't need skinning because you don't have bones. So we can export that. Let's call this to cloth shapes. Export. It's going to go do it. Slowly. This takes a while because it's going through and writing a file for all points with a keyframe for every frame that we've done. And it can take quite a long time, depending on the number of frames you're trying to bake. So let's talk about why this looks good, but it's a bad idea when it comes to exporting for a game engine. Because the truth is, if you want to get that cloth look back, you can just export some of these keyframes and do some blending between them while you're also applying the bone animation, and get something that is much better approximation, kind of a hybrid between the two, to get that inflation effect of the wind blowing across the shape, while still being controlled mainly by a keyframe bone animation. I'm not going to go into detail on how to do that. It's basically just it would be a combo of the bones animated with some shape keys, less shape keys than what we have here, because this is 1,000 shape keys, which means it's 1,000 times however many points we have or vertices we have on this mesh in terms of instructions for animation. And the downside is that those shape keys, like I said, they linearly interpolate. So if we took this beginning shape key and the end shape key and we got rid of all the shapes in between and did an interpolation, it's going to kind of warp on itself and go straight through itself, because that's the points are just going to take a linear line from one position to another. Whereas if we apply the shape key after the bone animation, their linear interpolation is going to be kind of constrained by the position of the bone holding the cloth in place, and it's just going to you can do a relative transformation, and that's going to cause just the shape of the cloth to kind of change, and that'll take a lot less shape keys. So now we have our exported GLB, which is 36 megabytes, which is kind of too big for, I'll show you that it translates though. Let's just go to Mozilla Spoke, and I just like to do this just to show you that it can animate. So here's our other cloth animations in this, one with the bones, one with the keyframe or the baked shape keys. I'll get rid of that one, and I'll import the model we just exported. Right there. It's going to take a second because it's big. Just for comparison, this, it had less vertices. It's 38 megs, 36? Yeah, 36, 37 megs. And this one with more vertices and bones was 6 megs at 3,000 keyframes instead of only 1,000. So twice as many 3 times as many keyframes, more vertices, and a much smaller file size. So you can kind of see it's just too big for certain use cases. There may be ways to compress these point caches. I've tried doing half of the shape keys and interpolating between, but like I said, they tend to do this linear thing that just doesn't look very good. So if we take this in and turn off collision and put the animation. Ooh, did it not export with an animation? Or it's not in there yet. So yeah, it's taking so long to... So there's our model. Here's our animation. And if we hit publish, it's going to take a while. So you can see this file size now is 50 megabytes, partly because I have the other one in there as well, but it's also a lot of triangles, a lot of animation, a lot of unnecessary stuff. So let's publish. It's going to take a while because it's uploading it to the server. So So you may be asking, well, what's the point? Like, why do I care about baking cloth animation to bones to take into a game engine or whatever? This is a good example of a reason why you do that, because this guy would be a real pain in the butt to hand animate. You've got these features in any 3D software that allow you to simulate cloth fairly realistically and easily without having to do hand keying, even though it's still a lot of work to get the translation or the transfer to the bones. It's not nearly as much work as it would be to get a good cloth simulation animation and key that across 60 bones. It's almost, I haven't seen, I would not want to attempt it myself, let's put it that way. I'm not saying somebody couldn't do it, but it would be very labor intensive and take you a lot longer than just doing a simulation and then transferring it to some bones. So let's just take a look, make sure that it came in, and show you kind of the difference between the two methods and see that it's really not that big of a trade-off. It's going to take a minute to load. So some other reasons why you might use this cloth simulation is when you're doing something that has kind of more of a fluid motion and you don't want to have to. So you can see, here's the one I just brought in. There's the animation, and it's got that nice kind of inflated bending cloth look. But for 36 megs, is it really worth it when you can get twice as many keyframes and the same kind of effect going for much smaller? Probably not. So there's our cloth simulation. Let's go and talk about how to do it the smaller way. All right, so what you want to do, go to, let's see, one of the front views and add a, see, we're in object mode. You want to add an armature, single bone. We'll turn on wireframe so we can see what we're doing here. So when you do that, it's a really big model, so there's our bone. Sorry, it was interior. Let's go to, there we go. Get it in place. It can be down here on the base if you want. And then go in edit mode. Grab that top head to the bone and just take it. We're just going to leave it at 3 here. Doesn't have to be perfect because it's going to stretch. So now if you hit Control E, take it up 2, Control E. Oop. All right, now what? So we've got this skeleton we just created that mimics the shape. We want it to target points along the cloth simulation. Okay, so man, I buried this. So I've got kind of these baked shape keys, which will work fine. It's the same idea. If you've got the cloth simulation, it's the same as well. It doesn't matter. So this is a little bit different. Don't assume that you have to have gone and exported the shapes as a shape key. In fact, let me copy this armature. I'll just bring it in on the other one. And we'll get rid of everything but copy objects. Let's open. Which one was it? Yeah, that was the one to bake. Actually, I could just go and reopen this one since I didn't save it, and keep the simulation now. So now I'm back to physics, and let's see if I can paste those bones. Yep, got my armature. Let's go wireframe. So there's the armature in place. So what I was saying was we need to create our rings for control. So let's take the mesh, select the edges, and just double click wherever the bone tips go and make a new, call it ring group. Then assign that ring. Okay. So now if you hit select, there's that selected. Deselect, do this one, new one, ring 2. Assign, ring 3. I know this is a lot of work, but it's a lot less work than hand animating this stuff, so. Assign, make sure, I like to double check and make sure each ring has the appropriate thing assigned to it, because if you make a mistake, it can be hard to debug. We'll make a new one, ring 4. So I'm going to go through, I'll probably skip forward a little bit on this, or fast forward, and create all of these assigning rings. So when I come back, we'll go and apply the constraints. Okay, so I've got the ring set. I just wanted to point out one thing that I had, because the way this bone happens in the center, there wasn't a ring to assign it to, but I do have these, let me turn this off. I do have these shoulder rings. And remember what I said, that if you select whatever your ring configuration that you've selected, the center of that in space, or its average between those points, is going to be where that thing's going to be targeted. And since that would end up being where this bone would point to, as it is right now. I just made those into their own target ring and called it chest, and then made everything else come out from there. So now we've got our rings set up. Let's go to, let's save, select our bones. We're going to go and add the constraints now. So if you go to pose mode, and you want the bone, select this one. We'll do it first. Go down to the bone constraint. We're going to add a stretch to constraint. Like I said, if we did the damped track, it works, but it won't scale. So stretch to is what we want. And stretch 2 and damped are not that different. So let me just show you. If I do a damped track and target our cylinder, so now it's targeting this object, but I want to hit that vertex group, that first ring. Now it's targeting that ring, and I'll do the same thing with this one. Just copy this constraint, just select that bone, and copy constraints to selected, and now we need to change the ring 2. When this thing animates, the bones are going to target the middle of those rings, okay? But you notice they're not scaling, they're just rotating. Whereas that stretch 2 will scale, will shrink the bone. And that's the reason we want to use that. But it actually behaves, it'll rotate the bone as well, like this damp track. So in some ways, stretch 2 is kind of a more advanced damp track. So let's get rid of those. But there may be times when you want to use the damp track. We're going to do a stretch 2. Again, same things, target the cylinder. And we're going to target that ring 1. Notice what happened, how it scaled the entire thing. That may be the, it's this rest length. If you hit reset, it's going to reset it to there, give it its right length. Basically, that was just, when you do this stretch 2, you've got to kind of have to set the rest length based on whatever it was scaled at. And you'll just hit this reset to get the length as it exists, as the armature was created. So if you get this stretched out weird shape, don't worry about it, just hit reset. We want to set our rotation to swing. It'll even say this rotation type. Use the smallest single axis rotation similar to damp track. So it's basically doing the same type of rotation as a damp track versus these, which will force rotation around certain axes. So we want to make sure we set the volume to none, and set the rotation to swing, reset, and make sure you hit that reset. Now we can copy the constraint to that bone. Notice that it's scaled again. We want to be able to select that bone to, notice it's all small, or maybe it's bone 1. Yeah, that one. No. Oh wait, I did copy, so we'll hit reset. Notice that it's aimed in the wrong direction, but I did reset the bone length at least. And we want it to target ring 2. And then we'll hit reset again to get it to the right length, okay? So this one is called bone, and it targets bone, or ring 1. This one's bone 001, and it targets ring 2. And we're going to go up the chain that way, and make it so that all these bones scale to each consecutive target vertex group. So we'll do this again, copy. I mean, we don't have to copy. We could select this and just add that constraint again. I just was showing you both ways to do it. So we'll do the stretch 2, cylinder, just less steps this way, and ring 3. Notice the scaling that's getting applied here. Again, that reset. Set it to 9 and swing. So there's a couple of different ways to get them. You can do the copy thing, but it's going to cause this weird type of selection where you have to kind of go up here in the Explorer and select the right bone to get it to do it. So sometimes it's better to just work up the chain, applying them this way. A couple extra steps, but this will be ring 4, I think. That one was ring 3. Yep. Ring 4. And notice that it, see what I mean about it? Each one of these, so if I do this one, is going to reflect throughout our cascade because they're linked in the chain. And I'll show you how we fix that in a sec. Cylinder, ring 5. So you see how it gets progressively scales that way. Even when we do this, so now they're positioned, I've reset them, but that's the same thing that would happen if we ended up trying to bake it this way. That's why we have to duplicate the skeleton, separate the bones, and then apply those copy constraints to make it do the exact same thing, but using different constraints so that when we bake them on a different type of chain setup, so that when we bake them, each bone is keyframed independently, and it just works better that way. So I'm going to go ahead and skip. All right, so just checking these constraints. I've got them all constrained with a stretch 2, pointing at the right rings. So now you can see that when this animates, the bones rotate and scale with the cloth. They target it pretty well, okay? So that's how you get those to target, except something's going on here. It's kind of weird. One of these may not have the See how the bones are kind of crossing over there, which is very. Oh, maybe it's that they're stretching because they're twisted. That's the thing. So if you watch, I thought they were. See how they take their shape, and then when they get rotated around. I'm going to cross over here in a second. See that weird kind of rotation going on right there. So there's weird you can see that bone, this bone, rotating a lot, where it's getting pushed back. This is going to cause issues with these rings getting colliding. So we probably want a bone in between that holds the shape. Because you want this bone to stay here, and you need something to force it to. So there'll be a bone coming off of this that connects to this joint, and it points at this ring. The same thing here. So what we can do is we can split this. So if we go into edit mode and there should be a divide, subdivide that bone. Then we can take, we'll do the same thing here. G to subdivide. Now we'll take this, and if we select the bone under its relations, make it connected so it snaps it back to the center. So now it's going to operate from that center point. Now we need to get straight on here. Just pull these into place. Like that. Should force this to kind of hold this shape more. So now if we go back out to edit or object, now our constraints are off because they're pointing at the wrong thing, but we can fix that. So if we go to our bones, pose, this one, this kept the constraint, so we can just make that instead of pointing at left arm 2, it points at left arm 1, which is this ring. We'll reset so it's in the center. Same thing, R arm 1, reset, and then this one will point at, actually we can copy from this. And instead of it pointing at L arm 3, it'll point at L arm 2. And then reset. That one's back to normal. Just reset. This one will copy. And it should point at R arm 2. Oops, wrong one. I had the wrong one selected. This one should point at R arm 2. Reset. And then reset that one. Yeah. So now, let's see what happens. Did I keep the... Yeah, I copied them, so I kept the volume stuff. So now when they rotate... Yeah, you can see where the orientation stays better, stays more on. It doesn't clash, they don't twist around on each other, which is good. All right, so now we've got that. Let's save. So like I said before, if I take this and I try to just bake these bones the way they work, let me save it, and I'm just going to show you what that'll do, what that'd look like. So if we select all of these bones, and then if you go under Pose, Animation, and then Bake Action, It's going to bring this up. We want to bake on the ones, only the selected bones. Oh, we do want to do this visual keying. What that means is that it will keyframe from the final transformations instead of, which doesn't matter on this particular one, but when we go and duplicate this bone, you're going to want it to take these. Well, you'll see what I mean in a sec, but let's just, as a rule of thumb, turn that on so that you end up getting all of the things that you're using or you're targeting in constraints, rather than you might miss a few constraints otherwise. So let's do that. Bake. It's going to go and do its thing. Again, this takes some time, but not nearly as much as the cloth. So now the deal will be, the thing that will break is because this is a chained set of bones. All of these scales that are going to occur, that are going to happen, are going to get reflected along the chain. Right now they don't do it because each bone is behaving and doing its scale after the parent. But once we lose the constraints, all scales will happen at the same time and it's going to warp. So I just want to show you what that looks like so you can recognize it and know what's going on if it has an issue. So now we've got all these keyframes down here. If we go to our cloth, well, actually, if we select all of these and then do constraints, I'm in pose still. So if we go under constraints and then just clear pose constraints, now we don't have any pose constraints on our bones, but the keys are baked. Notice it works for a second, but as soon as it starts to scale, things get warped off out of place, okay? So that's what's going to happen if you do this stretch 2 and you just try to bake that. Let's open our file the way we had it. That's why I saved it. Save. So now we're back where the constraints target the physics. What we can do to fix that problem is if we take this armature and just duplicate, copy and paste. Oh, I'm in pose mode, sorry. Object. Copy and paste. And it's going to copy and paste both because we've got a cylinder that we're targeting to when I selected it. So we got cylinder and cylinder 1. We can lose this cylinder 1. Delete that. Here's our second armature now. And we can go into that second armature. It's going to have those same constraints. We can lose those. Clear, yeah, clear them. So now, if we look at it, we've got one armature with some bones that target the mesh and the other one they don't. Okay? Our armature 01 does not target that. But what we wanted to do is target these bones in the first armature, okay? So what I suggest is finding a keyframe where the bones are out of the way. Like in other words, we can do this as we drag across and those bones move so we can see what's what. And then if we go into pose mode, select this bone. Now, the first thing we need to do is change the relationships of all of these bones. So I'm going to add a bone. Let's go back out to armature 1. If we go into edit, just add. So I'm on armature 1. I just want to add a single bone. And I'm just going to pull it so that it stands in a different way. I'm going to call this base. So I know what it is. That first bone well, that's bone 1. This one's base. Call it base. Now I want to unparent all of these other bones. I don't want them to be in a chain, so I can just go through this, select the bone, and in relations, so right now this one doesn't have a parent. I can select this one, which it does, and just break it. So now it's going to be flat out in the chain. Or even better, instead of saying breaking it, I can just target base, and now it's going to become a child of base, which is what I want. Put that one in base as well. This one will end up becoming base. I'm just going to make base, but it's not going to be connected. Undo, hold on. I want to lose the parent first, so that when I do reconnect it, it offsets the position and doesn't try to connect the bone. That's why it jumped to that place. So break the parenting first and then rejoin it to base. So break, then back to base, break, back to base, skin. Now, what we want to do is select this. Go into pose mode, and at our constraint, we need a copy location. We're going to target armature and bone. And that's fine. And then we can add a copy rotation, armature, and bone. So now you can see where it's doing just about everything that bone's doing, except, I don't know if you can see this, but the bone that I'm targeting ends here because it's scaled. And this one, because it doesn't scale, and this is why it was causing the kinking on everything else, because we're basically doing like the equivalent of a damped 2 on this right now, except we want that scale. So now if I add a third constraint, copy scale, armature 1, bone, everything takes, okay? And you can see that it separates itself from this second bone in the chain, right? So now this thing, the bone that I just created, will copy pretty much every kind of transform on the other one, and it's doing its thing, okay? One last thing though. This bone, when we do that copy scale, we don't really care about the X scale or the Y scale, so we might as well just copy only the Y, or the Z scale, sorry. We're only copying its squash, let's say, and that's what you want, okay? So now we can copy this bone to this. Right, let's get further out where they're out of the way. There we go. So we're going to copy this one, this constraint to this bone, select it last, copy and paste, and you can see where it does the same thing. Then you just want to select, make sure you've got the right bone, bone 1, because the other one was bone, and go to its constraint and just change out bone with bone 1. Keep the armature the same. You can see it's doing its thing now, okay? And now we're going to just go up the chain and do that for all of these bones. So select this one and this, copy constraints, and just do them one at a time. And then just remember to make sure that you're doing it to the right bone. Select, look at the bone, we're on bone 2, which would be the third in the chain. That's right. Change it from bone. And the other way to see if it's right is if it's called bone 2, but it's targeting bone 1. They're going to target the same bone that they are, so you want to make it be equivalent. There you go. Okay, and you're kind of like, well, what's the difference? Well, the difference is that these don't connect to each other, so all of these individual scales are getting applied individually to the bones, and when we go to bake them and remove the constraints, they're going to hold instead of skewing. Okay, so I'll do that for every bone. All right, so save this. Now we have those constraints copied, and these bones are the ones that we're going to want to bake. Okay, so these are the bones that have the triple kind of copy, location, rotation, scale constraints. And they're targeting the original armature, which we can now turn just visibility off. So we select these bones, make sure everything's behaving as you want it to before you go and do this. Save this, and then go pose, animation, bake action. We're going to do only the selected bones that we have because we've selected all of them. And then truthfully, we don't have a constraint on this one, so we can leave it alone. So I'm going to drag select all of these and not select the base, just because we only want less keyframes. So go pose, animation, bake action, leave it at 1, and we want to do visual keying because if we don't do visual keying on this, because these are targeting other constraints, other bones, and other armature, they will not bake the action of what's going on from the constraints in this armature. By doing visual keying, it's going to make those constraints happen first. All right, so visual keying, We'll leave it there, bake it. All right, so there's our keys. Now if we take and select all of these and constraints, clear the pose constraints. Those actions being baked, the bones are still going to take their place and do what they need to do. Okay, so now we have the bones actually baked, which is good. We can lose pretty much everything now. So we can lose, well, almost everything. We can lose the original armature that we copied everything from. So we'll delete that. We can turn off, go back out of pose mode now. We can lose the cloth on there. We can get rid of the floor and the wind. Now we have this bone that wants to do its thing, and all we have to do is bind this mesh to this bone chain or armature. Right click and parent with automatic weights. And then you get this. Okay. So now we have our physics baked to a bone chain controlling the mesh. You can save that as something else so we don't lose all of that other. So we can go like this could be toot baked. So that way we have a version that just has the cloth baked to the mesh, to the bones. Okay. Now, like I said, it doesn't look as good as the original cloth simulation. It doesn't have the wind blowing and causing the cloth. It looks overinflated. But you could take those, because the mesh is exactly the same, you could take the cloth baked keyframes and pull some of those back in and use those like every 20 frames, every 50 frames, depending on how often it bends. Basically kind of decide where to do it and just copy those keyframes and paste them as shape keys and apply them relatively so that the mesh is still deformed from the skeleton, but has the cloth kind of billowing going on it. And then you can, you'll get the best of both worlds. So what you would probably do from here is go and seam up the mesh, paint your texture to look however you want, color-wise, material, whatever. And then export that as a GLB to take into WebGL. So let me show you what those look like. What we'll do is we'll export. You want to select the armature, select the hierarchy, so you get just the bones and the claw or the character. Export. We'll call it GLTF. To cloth baked is fine. Include selected objects. And under animation, we don't need shape keys. And this is all okay. And skinning we do need this time. Oh, let me show you one more thing. So one of the advantages I told you for doing this was that, let's go to animation. And in pose mode, we'll select our armature. Let me get the right bone. So you see all these keys. We're starting off in a T-pose. We don't want to do that. We want it to start. We don't want it to like reset if we loop this animation, so that we don't want it to we want it to loop with this, right? So what we can do is basically find something similar to that position we're going to copy that last keyframe, but we want to go back to where he sends something similar to that pose. Something like there. Maybe even that. Zoom in on those and delete these keys before. Let's just drag select. Let's go ahead and delete that one. I just need some space to be able to drag these keys like there. Delete those. So now, what is going on there? Oh, I only did it on one bone. I want to do it on all bones. Sorry. With them all selected, just select the summary key up here, and that'll delete them all. Then you can select those and delete them. Now he'll start at that position, right? But that position doesn't match the end key. So what we can do is go and copy the end key. Just get to it. I'm just dragging this trying to get to the last frame. There we go. Select that end summary key with all of the bones selected and copy it. And then go back to your frame where you want to paste. Just have to kind of get the pacing here, so then we'll go here and paste. Oops, I didn't copy that frame. Bear with me. Sometimes you might hit Control C, but it might not do what you want. I'll show you how to. You won't have that problem if you right click. So with that selected, copy there, deselect, come back to frame 60. And then we'll paste. Now we've pasted only one of the keys. I thought I had them all selected. Paste. There we go. So that when he'll assume that shape, so it'll loop. So we'll go from the last frame to that frame. And maybe that's not the time that we want to do it over, but I'm just showing you how to get it to blend. And then the idea is, since that's on 65, we'll just set our start to here to 65, which will set our play range. And if we hit play, it's probably not what we want it to happen over. It's too easy of a transition, so we'll go probably from there, 70. All right, so then trying to make sure we've got, oh, one of the other things we can do now that'll make this thing play better is since it's applied, we don't need all these other vertex groups that we created, the rings and everything, so we can go and delete those. We'll keep base since we have a base bone, but we will delete ring. Let's see, basically from alarm 7. So we're going to just go up. Keep the base. So now we have just those vertices. Yep. And let's see our playback. So you may need to clean up the weights a little bit to make it behave how you want in terms of the shoulders. But that's how you end up baking this. So we've got the animation where we want it now. And it should loop. Kind of messily. It wasn't great. It wasn't a great keyframe copy, but you saw what happened. So anyway, we can do better. But I'm going to leave that up to you. Then we can select the hierarchy and export our GLTF. Call it tube cloth baked. Geometry, include selected. Geometry is fine. Animation, we don't need shape keys. Hit export. Now that was a lot quicker. And if we look at the baked for that, we get from 36 megs to 1 meg for the same, roughly the same animation. Admittedly, this is kind of a true cloth vertice by vertice bake, and this is just the bones. But it's still pretty good, and it's much smaller and easier to handle. So then from there, if you want to pull it into augmented reality, it's fairly simple. If you go to this AFRAME, Jerome Etienne GitHub AR.js AFRAME, then you're going to get the latest version of AR.js. And there's some example code here towards the end where you can... you set up these entity places. So it's going to be, these are some new ones actually. It's kind of interesting because I haven't seen that AR toolkit, which is Apple's marker stuff, or Apple's like AR core basically. So this actually may be a different AR.js. Anyway, if we go here, this will take us to the GitHub repo so we can see the examples. But here's the official documentation off of AFRAME's site. And this is the blog post, image tracking, and location-based AR with AFRAME and AR.js. So if we go to the official documentation, which is here, then down at the bottom, you're going to look for, so you can do targets, image targets, which will track based on an image, or you can do kind of like a Vuforia style tracking, which will just take an image, but you'll have to create those targets. The one we're looking at here is actually geolocation based, and what you do for that is down here under, here's the image tracking example, here's the location based example. You can just copy this code, not much, and we will go to our models. We'll make a new text file. Let's see. We'll call this air guy, AR guy, example .html. Yes. We're going to open that in our text editor, in this case Notepad++, and paste. There's our code. The main thing here is that we have AFRAME 1.04. We have a look at component, which will cause the object to face the camera. And then we have our link to the AR shim for AR.js that works with AFRAME. And then from there we have a scene. So we turn off VR mode. We use AR.js source type webcam. So we're going to use our webcam as the background and turn off this debug UI, which will tell you distances to objects and things like that. You can turn it on if you want to debug. And then from there we have this a text object, which is just creating a text that will play in space, giving it a certain scale, and then you can add a longitude and latitude. What we'll do is show you how to take assets like our just exported guy. We're going to put that after our scene. Let me make sure. Yep. Right here. So we have this A assets, which is just an asset loader. We're going to call it, we'll leave him a air guy. And then from there we can just target. So it's going to be relative to this HTML file. And I think we saved them in the exact same folder. So if we go to our 3D models and copy our tutorial, baked this guy, and just make it ./that. There's the link to the object. We're calling him air guy. And then what we need to do is, instead of using this text, we're going to keep that for a second because we're going to want some values from that. We're going to paste an A entity, this guy, and put it in there instead. So an entity is just an empty node. So we're going to give it the air guy entity. We're going to make it so that it looks at our camera, and it's going to have a scale of 1 to 1, 1, 1, and 1, because we're not going to scale it up or down yet. This location is going to be your latitude and your longitude. And if you give it a position right after that, then it would be like 0, and then the middle one will be your y. That's going to be your height, your altitude. So normally if you don't add a position to it, it's going to just sort of place it at the ground zero to your object. Otherwise it's going to, or place it relative, it'll default to whatever your starting altitude was. But then if you want to say, well, I want to put this thing up on a mountain somewhere, and I don't want, and they're not going to start on the mountain, they're going to go looking for the object like Pokemon or something like that. You're going to want to know the altitude of that point. What you can do is go to Google Maps. So let's say, let's just do Google Maps. This is going to come out relative to my location. But let's say we want to put it on top of this mountain, Kennesaw Mountain, and I can recognize it better from a satellite. There is a mountain here, right? Over here, there's a peak, which is the highest point, the summit right here. So let's say we want to put this guy on the summit of Kennesaw Mountain in Georgia. We can take that point and you'll see its longitude and latitude right here. So you can copy those. Or you can get them from up here. So if we take this and just move this position, whatever's in the center of the screen will end up being the output here. So here's our latitude. Go into our file, paste it, and then you're going to want the entire decimal places because that's one of these decimal places can end up being a large chunk of space, be out of position by a lot if you try to round it up. So you want that. And then it's at 39 meters right here. And that's going to be 39 meters, I believe, above sea level, which seems weird. Here's the latitude, or the longitude, sorry. So there's the longitude, latitude. Now, right now, if you were down at the base of Kennesaw Mountain, if you were, let's go to the map. The difference between, let's just go down here. Down here, see how it says 235 meters right here in the center. It says 241 meters. And then when you get up here, it says 159. And I don't know if it's giving you an inverse. What you can do to get an accurate height representation is you can plug these values into a lon lat altitude calculator. Okay, so yeah, it gives you the sea level. That's what you want, is the location. So let's go to where we were at, down in Georgia. For those of you who don't know, that's my accent. Let's see, yeah, up here, Kennesaw Mountain. Right up there, so we want this point. There's our height. So the difference would be, like down here in the parking lot, it's going to be 343 meters, and up here it's going to be 506 meters. Or if we go up here at the top, 526, I think that's the peak, 525, 533, let's do that. But put it along a path that they can actually get to. So there's our height. We go to our document. Now, we don't put that here. You can't put it in on the the entity, but you can put it on the position. So it's going to be 0.0, and then that, and then 0.0, and that's going to be our position for this entity, and that's going to put it up at a height then. Okay, so we put that there. Here's our air guy. We're targeting this ID from the asset. What I've done is I've nested an entity inside of an entity, just to kind of keep it simple and easy to understand, because he's going to also have this animation mixer, which we're going to need to target from this script. Copy that, and this is from Don McCurdy's AFRAME extras. So if you go and you look up Don McCurdy AFRAME extras, there's that, and then you can find the CDN for it right here. Just copy this. Go to your file and just paste it in after it'll be the last script. Make sure you put it after the A-frame's loaded. This A-frame up here. Make sure that's the right, that's the right version. Okay, so that way our animation that we've gone through all this trouble to bake, when you put this animation mixer component on the entity, will actually play that animation. And other than that, if you wanted to scale it up and make it really big, you could do that here. But I'm just going to leave it at the scale that it comes in at. So it should place it at 533 meters above sea level, which is where we'd want to put it. And then these longitude and latitude, and just to be on the safe side, since I did copy that from something else, we'll copy these and make sure we use those for sure. So like I said, a little bit changes a lot. And this one, I like that you can get this. So remember this map coordinates.net. That's a handy way to get all of what you need, and a little more accurate than trying to do it off Google Earth. There we go. Save that. And then we can lose our text. If you wanted to put text on it or have some text, you could always do that. That's part of AFRAME. The other thing is that remember that we're using this look at component right here, this, and targeting GPS camera. If you look at that, that's basically the ID of the camera down here. So that's how we target it, so that the camera will, the object itself will always face towards the GPS camera coming from your device. Now if we save that, now you can run this on a computer. I'm going to show you what that looks like. Just got to find the file. This AR guy right there, example. So what we want to do is we want to run that from, if you try to run it on your computer, because we're loading the GLTF, you're going to have a CORS issue. I just happen to have a Firefox that's modified so that I don't run into that issue. So this will show you what it looks like if you open it on your computer. It's going to say, okay, use your screen cam. Yep, we do want to use that. So we have the background. We want it to have location access. And we don't care about the virtual reality part for this. So now, there I am in the corner. But it's gone and positioned the file, the guy, way up high, that 533 meters. So let's just bring him back down so you can actually see him. Turn that down to 0 for now. Save. And reload. See, there he is. So we're going to say allow. Don't allow. And there's our animation. He's right on us. So that's the way, and you can drive around. Like if I drive back, I'll be able to see him better. I'm just holding down my W key. So there's our animation. He doesn't have a material, so he shows up a little dark, but that's how you can see. So now if we open this, if we put this HTML file and the object up on a server like a GitHub and save it there, then you'd actually be able to open this on a device, a remote device, a mobile device. You'd be able to do it and see this at that geolocation that you put it at, similar to the video that I showed at the beginning of the beginning of all of this. Let's see, where did I put it? This guy. So this is me after I've hosted the video on GitHub, or the guy, the object, the text, the HTML file, and the object, and I located it near my house, and so you can see as you walk towards it, the camera, the A-frame or your virtual world camera tracks with you towards the object. The object will get bigger on the screen. It's holding its trying to hold its location relative to the geo-position that I put it at, and so it's sort of it's at that position in the virtual world, but the camera tracks to it. So that's how you end up trying to do like a complex animation and positioning it in sort of a WebGL application, in this case augmented reality. So if you wanted to make your own Pokemon Go game or something like that, I won't say it's easy to do, but it's a lot easier than it used to be. And you have the tools, and the cool thing is you don't need your own, you don't need Unity or something like that. You can basically do it as a web page now. And using these AFRAME and AR.js tools, you can basically make it happen. You need to know some JavaScript and some stuff like that to make the gameplay elements, but it tracks pretty well. And in terms of this jerkiness that you see, where as I rotate the camera, it kind of shifts, you could easily lerp that. Lerp means to just interpolate between keyframes. You just have to dig into the roots for A-frame. And to be honest, by the time you actually try this and come up with it, it may be that somebody's already come up with some code to do it. So look up smoothing out camera tracking, A-frame, AR.js, something like that, and see what happens. So anyway, if you have any questions, just post them in the comments. Hope you liked the video.